Just like with systems of two equations and two variables, we can sometimes get unusual answers with systems of three equations. That means we might get no solutions or we might get infinite solutions, and we need to know how to recognize that in a matrix. So I have this system of equations here, and you would translate that into a matrix by using the 6, the -1, -1, 4, etc. And I've already put that into my calculator. So in my matrix, I've gone to the edit and I've already put all of that information in there. And then when I go back to the, go back to the matrix here and ask it to do the math, the reduced row echelon form, so letter B, on matrix A, which is where I've just put this, it's going to give me this kind of funky looking answer. It's got all these decimals and stuff, and I scroll over and it's just like looks really weird. But I notice that these numbers are repeating, so I'm going to try to turn it into fractional answers. So just don't do anything. As soon as you get that answer, go to the math button, say turn that answer into a fraction for me. And now I've got some nice fraction answers here. And all I have to do is kind of scroll over to see the rest of the matrix. Okay, so if you take that, and I've copied it down so it's a little bit easier to look at here. That's 1, 0, -2 sevenths, scroll over, 7 elevenths, okay? And then 0, 1, -1 11th, and -2 elevenths. And then the bottom row was all zeros. Now remember that each of these can be translated into an equation. So what's that top equation really telling me? That top equation is telling me 1x minus 2 elevenths z equals 7 elevenths. This is saying 1y minus 1 11th z equals -2 elevenths, and this is saying 0 equals 0. That means I have no variables. That's a true equation, infinite solutions, just like for systems of two. When it's using coming up with a solution set, I would say then that z can be any number it wants to be, and I can solve for x and y in terms of z. That's why we call it a dependent system. Just to get my answers for x, then I just take this top equation and get it by itself by adding the z term to the other side. Same thing for the y. Add the 1/11th z to the other side. And so our final answer could be written as this kind of messy looking ordered triple, right? This big complicated mess here for my x, then this big mess here for my y, and then z is just itself. Now I want to point out that sometimes we get no solutions as well. If the last row ends up being all zeros on the variable side and then a different number on the constant side, that'd be equivalent to saying 0 equals 7 maybe. That's false, so that would be a no solution system.